All right. So what we had discussed previously, we had just a small discussion around, uh, RAGs. So we were discussing that how RAGs, it's a very basic form of RAG, how does it works? So you can take your external documents, you can take all of your external documents and then we can divide it into small pieces, right? And then we can use an embedding model. As of now, we were using all mini LM L6v2 model. You can even rely on any like OpenAI embeddings, Gemini embeddings. There's a complete leaderboard on embeddings actually. Embeddings leaderboard. I do not know this is active as of now or not. Okay, it is loading. So, you know, see, these are the best embeddings that are available as of now. But again, Gemini embedding, then we have Qwen embeddings, and our embedding model will be somewhere. Let's see, embedding. It has moved quite down because these are very huge embeddings, their size is very huge. BG embeddings and then GST void shell 5 static. This is all mini LM v2. My proper embedding name was mini LM L6. This is v2. They have not given. I guess this is a more advanced version. All mini LLM L2 v2, right? And similarly, this is the one we are using, I guess. Yeah, we are using this one L6 v2, which is having quite a good performance, but performance per task. Let's try to have performance per task. So yeah, here is our embedding. If you see mini LM, the open source one, which is doing quite fine on most of the tasks, not very excellent. But if you have to use, Qwen 3 embeddings are again free of cost embeddings. But again, you will have to spend some money on your infra and everything, right? You can just go ahead and you can use these benchmarks. There is also LLM leaderboard. So basically, we will see how to benchmarks, how to build benchmarks. Sorry, we'll see how to build benchmarks. Now, if you see, uh, now these are not always reliable. This is just for the reference, right? It is not that, if they are good on these tasks, they are very good. They are good on these tasks because they were fine-tuned on these tasks. Whether it will be able to run on your task, you will have to evaluate it. Until unless you do not evaluate it, you will not know. There might be a chance that, Qwen or any other model, Mistral model, might work better on your task because it was pre-trained on that specific kind of a data set. But just for the reference, I mean, for generic reference, we can have a look at this and then we can decide. They will have, I guess, some of the paid. I do not know. They earlier they used to have these paid models benchmark also, but as of now, I don't see any of them. Yeah, as of now, I don't see any of them. Now, these are for the small embeddings for edge devices, right? 3 billion models. Then we have Qwen 2.5, 1.5 billion model, and all of those things. And if we see Qwen 3 billion, not Qwen 14 billion, 14 billion. That's not able to search. Okay, 72 billion, 7 billion, and then we have, I do not know where is 3 billion. We'll have to search it out. Right. Anyways, not an issue. So basically, you can have a look at, how it is performing on all of these like benchmarks and all. And there are many other benchmarks actually. It is not that this is only one, but yes, I mean, many other benchmarks can be a bit biased, you know. So let's say, I mean, we have these one Grok 3, then we have Grok 3 high school maths. Grok 3 is better. In agentic coding, Claude 4 is the best one, and it is actually a very good model, Claude, right? In some of the reasoning, Gemini is better, right? And in some of them, this open source model Llama is better than all of them, you know, which tool has to be used, right? So now we have actually stepped into a very important use case that is, will soon uh, go towards these agentic use cases. But first, what is that we need our LLMs to take decisions on behalf of us, right? This is a very simple thing that what do you do with the information, right? This is just for the reference. I'm trying to tell you that, yeah, this is how we'll go in the future. You have your company data, right? You have all of your company data. You have all of your company data, and you have all of this data, and then all of this data is basically uh, okay. You have your AI models, right? You have your AI model. As of now, we are using two AI models. The first AI model is your sentence transformer model, right? Which also sentence transformer, right? It is your sentence transformer, which helps you in converting text to embeddings. It helps you in converting text to embeddings, right? And then next to this, you have your, your LLM model that helps in crafting answers. It
Amit?
helps in, yeah.
Yeah. So when we say it is converts text to embedding, so this is an encoder model, right? Basically,
This is an encoder model.
it
Yes.
just encodes into the context vector.
Sentence transformers are mostly encoder, right? Mostly encoder. The sentence transformers, right?
And this LLM we are attaching to decode that decoder.
We are not decoding here. So basically, what is happening that let's say you have text, your text gets converted into vector,
Right.
right? And you have then vector database where you have lot of vectors v1, v2, v3, v4, right? Now you have a query coming in. Again, you will have a query. Let's say we'll just have a small example again today. This time I will use a bigger corpus to demonstrate you. Let's say we have query. We will again convert it into vector. And then we'll see that this vector is resembling to which document in my document store. Let's say this vector 0. Vector 0 is very much resembling to v5. Then you have pulled out an answer to your query from your corpus, right? Now you give this to LLM.
So this is calculated it's based on the distance difference, right?
Cosine, exactly.
Cosine. Okay.
Cosine similarities. There are some other ways also, but as of now, basically, the better the model is trained, the better will be the cosine similarity, right? I mean, let's say if at all the case is that uh, two sentences are similar. Let's say two sentences are not similar in English context, but in biology context they are similar. Then in that case, let's say this is English one and this is sentence one, sentence two, let's say, right? They are far away. Then you will have to fine tune so that automatically they come close to each other, S1, S2, right?
And this
This is
generates words only based on the material, right? Doesn't it is not generating own words, right? Whatever content it has in RAG, only that is responded, right?
ideally yes, right? Sometimes if your LLM is not hallucinating,
Okay.
right? We have to make sure that our LLM doesn't hallucinate, right? If it is not hallucinating, there is a complete hallucinating board also that tells which model is hallucinating and which model is not. So if it is not hallucinating, it should answer from uh, existing corpus only,
Okay.
right?
Yeah.
Okay, sure. So this is what we are doing today. Before we start, our LangChain example, or we can cover the same example in LangChain also. I mean, uh, the whole point being that even the LangChain is built on all of these things. So we can just have a look at small example. We will try to load a small book here or a chapter from the book. Let's say I'll just go to Colab. Right. We have this our RAG systems. Okay, this is all we had, and we will have to again reinstall some of these things. Let me start with the installation, as it will take some amount of time. Right. So what I will do is, I will just take any. This is the project Gutenberg. Let it install in the meanwhile. Right. This is a book here. The complete book is present from chapter 1 to chapter 12. The book name is Alice in Wonderland, right? So we will use this book, right? A small story book for children. We will use this book as an external corpus, and then we'll try to ask some questions. We'll try to load it into, as of now, our uh, that is load it into vector DB, and then we'll try to ask some basic questions, right? Install transformer, torch, accelerate, bits and bytes. Bits and byte transformers, sentence transformers is not installed in spicy. Okay, so reading from complete book. Now this is again a small document. Next, going forward, you can have a huge document put together. Right, it will take some amount of time. Okay. And let me install this also. In the meanwhile, let us upload our book. So first and foremost thing, you will have to convert your PDF into text format. No matching distribute sentence transformers, I guess. You'll have to convert all of your data into text. Now, like I said, even previously that, converting the PDF to text is not a small job. You can go ahead and use Docling. I'll demonstrate the use of Docling once, right? So this is a Docling is a very fine library. What it does is basically it's very easy to use. Let's say if you want to convert anything to your, Markdown or PDF or anything, so it will extract the metadata, titles, authors, reference. I mean, this is, I guess, okay, coming soon. It will parse multiple document, PDF, docx, pptx, wave, mp3, advanced PDF understanding, page layout, reordering, table structure, code, formulas, image classification, and more. So yeah, I mean, this is a small library that you can use. We'll demonstrate its use. It's very easy to use. Right. We have this done. Okay. Right. And now let's actually go for building that. So let me first simply install torch from transformers, import pipeline from auto tokenizer, auto model for casual LM. Okay. Next, we'll use the model underscore name. I will use 1.5 billion model, Qwen. So let me go ahead and search for Qwen 1.5 billion Instruct model. What is the difference between normal model and Instruct model? They are fine-tuned further on instructions dataset. I could have used normal. I mean, why did it fail? Import torch from transformers, auto tokenizer. Okay. Okay. Import pipeline, auto tokenizer, auto model for casual LM. What is the problem now? Auto model for casual LM, I guess. Okay. So what I was telling you that, what is the difference between these things? That they are further fine-tuned on instructions. These are called as base models. If you go here, we have re-ranker model also, which we will discover in our further RAG sessions. They have their embedding models also, right? And they have various other models also. So Qwen 3 normal models are also present, right? Now, these are instruct models, right? And these are very much the base models. If you see, this is again an instruct model. I guess most of these models are instruct models itself. So some of them are base models, like they are not specifically fine-tuned for instructions. They are generally fine-tuned on, on general things. Some of the data sets they have provided here, and they don't release all of the data sets, these big companies, because if the data set is released, obviously anyone can, replicate these uh, models. So, okay. Yeah. So let's have this instruct dataset 1.5 billion model. Then further going in LangChain, we will use 3 billion model, but a different format of that model. Okay. All right. So let me load now Tokenizer and load Tokenizer and model using 16-bit precision or GPU, CPU. Okay, done. Model is trained, Tokenizer is created. Done. Let me load this. And then I will simply create a pipeline, which we had discussed in the first session of Hugging Face. Pipeline with text generation capability. Model is equal to model, comma tokenizer is equal to tokenizer. Let it load. It is 3 GB model. As of now, we are not using GPU. I hope so. Yeah, we are using CPU. So it will be a bit slower, but yeah, I mean, fair enough for all of our experimentations.
Anand, meantime, I have one just infrastructure question.
Yeah, please
The
go ahead.
collab can be very useful when we have some kind of experimental, quick
Correct,
experiment, right?
correct,
But
correct,
in
correct.
real times, for example, I wanted to do the same exercise through without collab. It's very difficult for me. Where should I go? Which how I can install that torch libraries or database storage, right? Vector database and all those things. So can you at least one session like to explain
Yes, sure,
if,
sure, sure.
if
Yes,
yeah, just similar the use case, right? That
yeah, for sure. What we'll do is one RAG use case I will run on my local, right?
yeah, yeah, that would be
So
helpful.
the best is I do not know uh, how many of you are aware with Dockers.
I'm aware about that.
Okay. Uh, so even if you are not aware, so Docker is a kind of virtual environment, very easy. You get a ready-made Docker on which you can run. So I'll guide. I mean, I will have one session on which I'll install everything on my local. So the reason I'm not showing on my local, I have all of the GPUs also in my local. I have 14 GB GPU in my local system, but I'm intentionally not showing it in my local. The reason being, then everyone might feel that okay, you have a heavy configuration system, so you're able to run everything on it. So how should we practice in that case? So all of these GPUs, we are struggling here for small GPU. I have 16 GB, around 14 GB of GPU, and that too RTX 4070 I have. So I mean, all of these models, including 7 GB, a full fine tuning of small 3 billion model, all of them I am able to run on my local. So I'm intentionally showing it here so that if you have to replicate any real-time problem, so you should not be struggling at least with these problems. But
Right.
one session we can keep wherein I can show you how to create a virtual environment, and it is actually very easy. Let's say if we have, even if you want to replicate this environment in your local, right, with CPU or with GPU, whatever it may be, we just have to know a list of requirements file. That's it. And there are certain 3 to 4 commands, and it will be just set. So I'll guide all of you. Don't worry.
Okay. Yeah. Thanks.
Sure. Okay. So my model is loaded and my generator object is created. Okay. Now next step is basically I'll have to, I'll have to read the book, the txt file, right? And then I'll have to chunk it and then convert it into uh, basically embeddings, and then store it into vector store. So again, the same step itself, but just for demonstration, I'm showing it to you, right? So from sentence underscore transformers, import sentence transformers, and import files. Right. Okay. Now let's say I'll keep my chunk size initially. Chunk size is equal to 300. I'll keep smaller chunk sizes, right? And chunk underscore overlap, I'll keep to 50. I mean, 30 I'll keep. Okay, 10% of overlap I'll keep. And then chunks is equal to the same chunking actually, right? There is no difference here. Start underscore index is equal to 0. And while start underscore index, okay, first I'll have to read this. Right. Book underscore text. We'll have to read this book underscore text. Right. So, okay. I have Alice underscore book. Read Alice slash book dot txt and do chunking with configurable chunk size and chunk underscore overlap. Okay. Chunk size is 500 what it has taken, and chunk overlap is 100 it has taken. Start index and got it. Okay. Here you have, so basically at the rate param, if you add here, so you can change it here also, 700, 800, whatever you change, it will be reflected here. So it becomes easier, Colab and Gradio are really good for demonstration, all of these things. We have chunks here. Okay. All right. Now chunks, okay, done. Total number of chunks that we have is 724 and done. Okay. Now next is I will have to load my sentence transformer. So embedding underscore model is equal to sentence transformer, and it was all slash mini LM all LM v2. We have embedding model, right? Done. And then, okay, loaded. And this is also 100 MB model. Next, I need to prepare my document underscore embeddings. So document underscore embeddings is equal to embedding underscore model dot encode. I'll provide it chunks, right? And that's it, I guess. If you want here to, show progress bar, show underscore progress bar, true, document underscore embedding. So basically it will convert all of them into embeddings. And then we can store all of these embeddings here. Dimension is equal to document dot embedding dot shape of 1. Okay, done. And now if you see, so basically based on this dimension, document, okay, it should be document underscore embeddings. Document underscore embeddings is not defined. Okay, so basically based on this dimension, we usually put the index. So whatever the index is, files dot index flat L2 and dimension, and then we go for index dot add the document embeddings, document underscore embeddings, right? And then we say that print all documents stored, all documents into vector DB. Okay, done. We have all our documents checked into our embeddings, and it did not show anything. Okay, batch is fine. Done. Okay. Next is basically what we need is we had already done. So next is the same thing that we have already done. Here we have to prepare the roles that, and then we have to generate the answer, right? Query. This is where we have already done. Next is prepare the query, code for retrieving, code for retrieving data using query. Who is Alice? And k is equal to 5. We already have query embedding, the index dot search, right? It is searching here, right? Right. It is searching here, then retrieved chunks, messages, and then the generated answer, right? The same thing what we had done. Who is Alice? Let's say. This model will take some amount of time. We're running on CPU, and see the model has taken 9 GB. Now please remember this, because the next I will be loading 3 billion model and the memory will reduce to 5 GB only. One thing that we have learned is quantization. There is one more thing that we'll learn is, we'll learn there is a different way to load the model also. So we'll just have a look at it shortly. Mm, 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 mm. Although when you want to, if you want to, this is for learning purpose, I had to load it directly on CPU. When you want to load on CPU, you should ideally go for, you know, uh, Llama.cpp, which we'll learn next, you know, using, because that is more optimized and it is faster than this. It takes lesser amount of memory. So we can run the model on, for our experimentation on CPU itself. We can run even bigger models on CPU. So this will be slower. We'll have to bear it for at least 1 to 2 minutes, I guess. Okay, we have, and it took 2 minutes. So the answer, it says context in, and where is the answer? Alice is main character. So this is all context it has given basically. Alice is main character in Lewis Carroll Through the Looking Glass. She is a young girl who finds herself transported through a mirror into a world. Things appear upside down and backwards compared to own reality. The journey leads her to encounter various characters from blah 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 XYZ. So basically it has also given me, the context from where the context it has taken, and then it has taken, five top five chunks, and then it has embedded the context. All of those contexts have been embedded into it, and then based on that my LLM has actually designed an answer. Now what I see that minute in a context in a minute, Alice began to be sure. Alice, I will have some tougher question. Let me ask a tougher question, because this I feel this was something even LLM knew, right? So let me say that query, what did Caterpillar say to Alice? Now I already prepared this query because I had to demonstrate this to you, right? What did Caterpillar say to Alice? And again, we'll have to wait for 2 minutes. Okay, let it complete. So basically, again, what we have done, in the meanwhile, we'll have our discussion. So what we have done in, this is what we have been doing. First is, again, your documents, you have text documents, you have chunking, you have embedding models, right? Embedding models, and then you ask, this is basically, you start you checking in your documents into your database, just like you have been doing it earlier, right? Just in this case, The thing is that, you know, these vector DB, we just have to convert them into vectors rather than the simple text. And then we take our query, convert it into embedding, and again we use a similarity search, and then we get the top answers, right? And then we give our top answers to LLM, and then LLM basically comes up with my answers, whatever the answer it has extracted. So it will come up with that answer, right? So this is what we have been doing, but this is not only what we'll be doing, right? There is more to it. And what is more to it? Let's have a look at it first. And therein the LangChain steps into. So till now, what we have seen, okay, here it is. Caterpillar asked Alice, this is my answer, why she thought she would tell him who she was before asking her name. I do not know if the answer is correct or not, right? We can actually go ahead and check what did Caterpillar say to Alice. Maybe it may have this knowledge. The book Alice in Wonderland. Who are you? Explain yourself. Keep your temper. Okay, so my answer is, it says, why she thought she would tell him who she was before asking her name. So quite, I do not know your recitation. Explain yourself. Just ask in slow and drawing voice. It shows Alice this first caption. Who are you? Right when Alice tries to describe her confusion. I mean, yeah. So it has given me an answer again. As of now, either I'll have to go to that specific, you know, I should go ahead and at least print that specific chunk from which the answer has been retrieved, and then I can verify that, okay, this is what it is telling and it is correct. So this is how a basic RAG will work. Now, but what all we have learned till now, what you have learned is basically that, you know, model. We have just learned about models, right? We have spent a lot amount, I mean, huge amount of time in learning, building models, right? Fine tuning models. This will always remain your basics, fine tuning. This will always be the basics. Most of the even courses online, they don't even cover this part because this is a tougher part, and they will basically either go through directly from the LangChain part or something. Now in the LangChain, sometimes then you will keep on wondering that how it is working from backwards. Today is it's LangChain, tomorrow it might be some other framework. Whatever framework it might be, you know, you will understand the basics and you will understand that, okay, this is how, I mean, let's say sometime you want to use Llama index. So the basics fundamentals remain the same. I mean, you don't have to worry about any of those things. But why do we need LangChain as of now? So what we have been doing, you know, we have been, all our engineering has been around the modeling. But now the next part of engineering starts, that we have our model, right? Part one we have finished. The part two is, you know, solving, auto solving, in fact, auto solving complex problems. Auto solving the complex problems. Now, what does it mean? Auto solving complex problems. This one. Auto solving the complex problems, right? Now, auto solving complex problems in the sense that, you know, model knows the answer. Maybe we have a complete corpus from here. We have complete corpus. No, sorry. we have complete corpus here, right? And we have this complete corpus. You have your model here, one model, or you might have, sorry, model M1, let's say LLM model. This is LLM model. This is your corpus, your huge information, right? Corpus, huge information. Then there might be other models also, like embedding model will be always there, right? Embedding model is, I mean, it is non-separable thing, right? Embedding model. Now, the point being that, let's say you want to solve something, a common example being, uh, let's say, I'm not, so okay. So let's say the example is that, you want to fetch the current news. You want to fetch, your model wants to fetch the current news right now, current news. And if this news will have any effect on any stock. I mean, this problem I was avoiding, the reason being, it is not affecting the business directly. I mean, the kind of businesses that we are working on. I mean, this is a useful example, but I was trying to crack on some very useful, something uh, related to us. So, okay, I'll just redraw it. Okay, right. So we have our external corpus of data. External corpus you have. Let's say, as of now, or I can take an example of supply chain, right? I can take an example of supply chain here. A simple example of supply chain. I have some that, this vendor is this and so and so. So let's say there is some order and it is from path 1. Then what this LLM can do automatically, the LLM can perform Google search. That is, now it has started to use tools. That is, it has started to use tools such as search, tools such as other things such as parsing, right? Or even Python. Python is a tool again for it. I mean, so that it can evaluate some expression if it wants, right? Any tool you can hook, any company tool you want to hook, you can hook that also. That is not, I mean, no, it is not that it is that easy to hook any external tool, but yes, I mean, with the right training and everything, we can do that. So it knows that, okay, what do I need to do? It comes up, automatically it comes up with a solution, a problem that, I have to ship my shipment to, let's say, JNK, right? There's a shipment that needs to be shipped to JNK from Gujarat, let's say. And then what it is telling is, okay, my another program has predicted that, okay, your best path is you have to go from Gujarat to Rajasthan to Delhi, and Delhi to then maybe Punjab, and Punjab to Jammu and Kashmir, and so on. So let's say this is something. Now, what my LLM can do, LLM can quickly then check, these are models. Model has already, what it has given, this model has given the shortest path. It has given the shortest path. Okay. And based on the data it has. Then my LLM can quickly go and it can check that if this path is, as of now today, if, let's say there is flood in the Delhi and that specific road from, or that specific way from which it was supposed to go is flooded. So then it will automatically give the feedback to the tool. You know what, you need to redesign the path from second way. You need to redesign the path from somewhere else. And then again, this is just one example, right? So basically it can use tools, you know uh, it can think over certain things, it can reason over certain things. Okay, it can ask over certain things. Whatever your output is, it can check those outputs, right? Agents can basically, all of these agents can get data from various sources. They can now they have started booking your tickets, browsing the data, and all of those things. Not very efficient, because obviously even today, uh, I mean, for ticket booking, still we have APIs and everything, so it doesn't make sense that an AI agent should manually go and search all of those things and book the tickets, because ultimately it becomes costlier as compared to even manual also. So yeah, so what it has started doing, I mean, there is a whole lot of bunch of applications that sit now on top of LLMs, right? That go ahead and sit on top of the LLMs. That includes agents, then the multiple agents interacting with each other, right? They using various models, and then they trying to solve some problem automatically without the human intervention. They're trying to use all of the tools. They're trying to develop automated reasoning and all of those things. So basically, all of these things we can go ahead and build using plain LangChain also, right? I can go, sorry, using plain Python also. I can go ahead and build using plain, but again, I need, if using plain Python, we can go ahead and build. Earlier, we were doing it using plain Python only. I mean, LangChain just came few years back. Before that, there was no such thing. And then we have LangChain. LangChain, basically what it does is LangChain does all of this, you know, uh, agent and prompt building, because now prompt builder will be one huge thing that we'll have to see. Prompt building, or even agents, you know agents, or even RAG architectures, various kinds of RAG architectures that includes chunking, PDF parsing, etc., evaluation, right? All of these things, it makes all of these things easier, because we may end up using many of these things again and again, right? Again and again we are writing the code and doing all sort of things. So LangChain just makes it a bit easier. Obviously it's a wrapper on top of all of the things that we have been doing. It just becomes a wrapper on top of all of those things. Now, understanding LangChains, I'll just display one small thing here. So now basically everything is going to ease out. Whatever you have learned till now, now everything is going to be easier as compared to whatever you have learned. All the tougher part is almost gone now, right? Now it's easier part. So what LangChain does is, what does LangChain gives you? LangChain, uh, it makes easier to load the models. Like I was telling you that this is not a very efficient way to load the models. What is more efficient? You can go for Llama.cpp. That is basically C++ version to load the models. Then I will have to assemble all of those things and do all of those things, and uh, do a lot of things, install a lot of libraries. But either I can go ahead and just install this LangChain. That's it. Now I can load the model from my local. I can load OpenAI. I can load Gemini, Claude, Grok, whichever. I mean, at least the most famous ones, Mistral. I can load any of these models, right? Just without changing my code or anything, right? I don't have to change anything. I just have to change one small thing, and everything will be simpler for me. Then on top of that, promptings have become complex now. That is, sometimes we need to tell to our AI that you have to include an example. I mean, let's say there are various kinds of prompting now we have, right? One is very simple prompting. Simple prompting is like, you simply say that what was what is, like, let's say 15, what is square root of 15, let's say what is square root of 15, and it will calculate. Maybe it will not, right? Now if it is not, then we say that we can provide some examples. To it, that what, uh, to calculate the square root of 4, this is how you do it. To calculate the square root of, let's say, 9, this is how you do it. So this is how you need to calculate the square root of 15 is the tougher one, let's say square root of 25, let's say, right? So we'll say it will say that, okay, if this is how you need to do, then maybe I will be able to solve it. So we are giving some examples to it, right? Or in many cases, we tell that, let's say the problem is something else. The problem is about maybe mathematical problem of uh, differentiation or anything, any kind of mathematical problem or differentiation or any kind of. But then we say that, you need to solve this problem using steps, right? You need to solve this. Let's say step one, you need to do this. Then step two, after doing this, you need to do this. Then step three, you need to do this. And then in step four, you need to Google search, right? In step four, and then in step five, in step five, whatever the results are, then you need to combine all of them. You need to combine all of them, right? So this is how basically you know it works. There are various other ways, React way of prompt engineering, but again, it is nothing. I mean, like the name is there. These are simply the ways, the way they have been trained. Some models, they have been trained this way, hence they will be able to solve the problem this way. Some models, they have not been trained this way, so whatever you do, they will not be able to solve the problem, right? So now, since you have seen all of that journey, you should be able to read the documentation, even run the model and check that, if at all the model might have been trained this way, the model might not have been trained this way, right? If it is giving you good results with certain prompts, certain prompting techniques, then obviously the model might have been trained in this way. If it is not giving the good results, then it is not. The other thing what I want you to remember is, like I said, LLMs, they are mostly concentrating on learning language, right? What we are trying to do, we are trying to make them understand reasoning on top of language. So that is an overhead, right? So sometimes if uh, after doing all of the agents and all of that, still your model is not working, then you can easily go for like fine tuning, right? Q-LoRa fine tuning. Most of the cases, Q-LoRa fine tuning is just more than enough. And with small amount of memory, you will be able to fine tune the data and your model will start working, right? In much of the complex cases, if let's say you're not able to even get it from RAG, I mean from data, external data you have, and your RAG is not performing well, then you will have to fine tune your encoder model, right? And encoder model can be fine tuned again using the same trainer API. Trainer API, it can also be trained using PyTorch, plain PyTorch, what we have been seeing for so many months, right? Plain PyTorch, obviously trainer API is more easier to do, right? Now, so these are various things, and then we have, on top of that, we have chains. So again, people have overcomplicated these things. Like I said, if the model is not capable of doing something, you may end up building any logic on top of it. It will not work. It will not work that efficiently, right? Models are not magical. First and foremost thing, we need to understand that neither is this AI anything magical. It's basically probability engine, matching engine, right? On top of that, when you have a LLM, they understand languages better, but again, they might lack in the reasoning sometimes. So by understanding all of those things, we can choose our model for the problem. Then on top of that, let's say chains are basically, what you can do is, such as we have prompt, then we use prompt, then we pass that output to LLM, then we pass that output to output variable. So doing all of that, basically you can just use piping operators, just something like expressions in the Excel, right? A different kind of expression. So you can use all of these things, and then you can build your chains around LangChain, right? Retrieval is again the same thing we have been doing. Let's say we have been using Chroma DB. Sorry, we have been using Fice as of now, but with LangChain, Chroma is more compatible. We can use Fice also. There is no such offense in this. But yeah, I mean, Chroma, more number of examples with Chroma are present. So we will switch to Chroma DB, right? And you see the tools I was talking about, the tools you can easily go ahead, you can perform your search. Let's say tools, DuckDuckGo search is something, I don't know if you have heard of it or not, the biggest anonymous search engine, because Google tracks every single bit of your search and everything. DuckDuckGo is anonymous engine, right? So DuckDuckGo, you can just use this DuckDuckGo search, right? And there are other tools also that are available, right? Along with Chat GPT and everything, there you can use Bing or whatever you want to use, right? Whatever is the comfortable one. This is just an example. You can use, I mean, calculator we do not have to use because calculator is inbuilt in here. And like I said, you can have certain Python programs and make them run and all of those things. Uh, they can contain the memory. Let's say if you're building a chat engine, because chat engine is a very common use case, nowadays. So let's say if you are building a chat engine and user was talking about something 1 hour ago or maybe 2 days ago, you can easily save them and you can recall them when the user is chatting again. So user, uh, I mean, it makes them feel like it's a real AI, that it is able to remember whatever the previous conversation was. It is able to draw any conclusions from the previous conversation and use in the current conversations. It has LangGraph. Again, basically LangGraph is a different data structure as compared to these. I mean, instead of using uh, data as vectors, we can use graph as data sets. This is useful in the cases, in specific cases, specifically like, uh, let's say you are designing anything for supply chain or something like that, right? In those cases, the graph is really important. I mean, it becomes really useful. Then it already has langsurf that allows you to expose your APIs, and then they have a langsmith platform. It is just for basically tracing and monitoring your AI agents, etc. Right? Agents, okay, agents also I have, right? So tools and agents, we can use tools and we can use agents here, right? So basically, let's say this is one agent that is responsible for Google search only. So we'll have a look at more complex agents also, and we'll have a look at few more frameworks apart from LangChain for agents, right? So it comes up with certain functionalities, and all of these functionalities we can use here, right? Now, time to get our hands on with this LangChain framework, right? So let's build a very easy and small application. Now, having said that, basically this is LangChain, right? This is LangChain. If you remember, I mean, what I started, the how you can build agents and everything, but we all started with the topic of RAG, right? Now, RAGs are not easy to command. So basically, we will be also covering few more tips and techniques along with LangChain itself, how to optimize this RAG. This is a very simple example of RAG we have discovered as of now. RAG, a very simple example, wherein we have taken small text here, and from that small text, it is able to answer very efficiently, right? So in real use cases, when the document is huge, I mean, there are a huge number of documents, or let's say, then even we have to manage the speed also and everything, right? And we also need to understand how should we evaluate our RAGs, because any system you can build, but if you're not evaluating that system properly, then there is no way, you will be just guessing around. There is no way you can improve that system, because if you do not evaluate, you do not have an evaluation matrix, how do you actually even improve that system? How do you say that after 6 months, whatever you had is still there and you have really improved on top of it? It can be it has improved in one area but degraded in other area, right? This is a very common scenario in AI, that AI improves in one area but it degrades in other area. So I mean, it is very important in that case. Evaluation metrics are very important, right? Now, having said that, since we have discussed enough about all of these things, so now we should go ahead and I will just give this thing a restart, or I'll create different notebook now for LangChain. Okay, so here I have, this is my 18th exercise. Now this time you get time of 2 weeks. Next week we won't be having the class. Like I said, I will be speaking at an event. So I'll make sure this Monday itself you get all of the videos and all of these notebooks. I request all of you to at least go and run the notebooks. If you do not do anything, it's fine. The aim of live class is at least you hear all of these things once, even if you do not go through videos, right? You'll hear all of these things once. So even if you heard all of these things once, just go ahead, try to play with the notebooks. Even just when you try to play with the notebooks, I mean, lot of things, you will recall, and you will again redevelop that interest in it. Right. So 18th exercise, spelling is wrong. Exercise, and then next is okay. This is about LangChain. LangChain 01. Right. So for this LangChain, we'll have to install our LangChain, and then we'll have to. So let me just install this time few more libraries. Right. I'll have to go with pip install. Now again, I'm not installing complete LangChain. I am using LangChain libraries as of now, which I require. We'll keep on adding them as we go ahead, right? LangChain community, and then for running my model in the local this time, I need is Llama.cpp Python, right? And then Hugging Face underscore hub. Got it. Okay. So basically, what is this Llama.cpp Python, right? Let's have a small discussion over it. I'll just So basically, for running these models, llama.cpp, there are few options available. First, we can go ahead with llama.cpp is the best one actually. Like we can go ahead with llama.cpp. Now, basically, the reason being, what it does is llama.cpp, it provides lot of advantages to us. First and foremost thing, it is mainly very convenient for CPUs. Now, it is not that it will not run on GPUs, but it is very convenient on CPUs, right? It is CPU optimized, especially for Apple Silicon chip. I mean, very much optimized for Apple Silicon. So basically, Apple Silicon chip and various other chips like Neon, ARM Neon, and all of those things. Chipset is very much optimized. On top of that, it provides quantization. It provides quantization, which we have already seen. Quantization it provides, but then on top of that, it provides GGML and GGUF format. What is that? GGML and GGUF format are basically, these are uh, formats that are mostly optimized for C++ libraries. These models are very much optimized. So if we go here and we go towards Qwen GGUF format, Qwen GGUF, we have Qwen 3, Qwen 3. Let me check what is the size of the models in Qwen 3. Qwen 3 coder, Qwen 2.5, Instruct GGUF. So we will use this, let's say, Qwen 2.5 Instruct GGUF format. So basically, this is a GGUF format that will run easily with Llama.cpp. Check out Llama.cpp documentation, Hugging Face Hub, and then you can easily, you can even run on your own CLI also. I mean, in the sense you can run them from the command prompt also, right? Even for GPU, I mean, the performance is excellent on GPU, right? Especially it is accelerated for GPU as well as for CPU. It might take some time to install, but let's finish. Okay, guys, we will first, in the meanwhile, model name, right? You can take 1.5 billion model also. I mean, with whatever is, 1.5 billion model will also be fine. It will be faster. Uh, we'll start with 1.5 billion model instead of 3B. When 1.5 billion GGUF. DeepSeek is also present here. Qwen 3, 0.6 billion, 4 billion, Qwen 3, 1.7 billion. Let me use this Qwen 3, 4-bit and 16-bit optimizations. Okay, let me try with this model. It is from Unsloth. Let's try. How does it goes? Then model underscore file where it will be downloaded. Qwen 3-1. dot GGUF. Okay. Model underscore path is equal to HF underscore hub underscore download. Repo underscore ID is equal to model underscore name and file name. Point 3.0, 0.6 billion. This is it. $1.7 billion, 0.3. Why it is not picking up? Onslaught. Base GGUF. There's only one GGUF. My name and that. Okay, I guess this is the problem. Let's try. This is a huge model. Then brain float 16. I will go for is block layers 0.3. Brain float I need with the float 16. BF16. 8. Let me try this. K underscore M Q3. Quantization 3. K underscore M GGUF. This is 940. Q4. Excel. I'll load this one rather than this. This is a, I mean, somewhat better model, less quantization. 2.33 GB. I hope it should not create problem in CPU.
So what was that causing the issue with earlier model, the
Yeah,
1.7?
we were not so basically what they have done is they have provided various quantization models like this is Q2 quantization. We can have a look at the size. This is brain float 16. This is the biggest quantized model,
Okay.
3.45, and so it was smaller in size, like it was some 700 MB model. So then I chose this one, 2.33. I mean, not very huge, not very small also. So we might get some better results in that. You know. So this was the only thing. Okay. Generate again now Llama.cpp. Okay. So now basically what we have to do is it will create a generator that uh, max tokens. I'll reduce this max tokens. Max tokens I'll keep it as 300 because number of total context I'll take as 1024 or 512. Right. Now temperature. What is temperature? Temperature is the randomness. Right. It is the randomness. Basically, more output will vary in every output will vary every time. Now, if you remember when we were actually creating our own models and we were trying to, so I did show one table uh, wherein every time a new word is generated, it has options that, okay, these are the list of options from which I can choose the sentence. And based on that, so more the randomness means it will choose from bigger space, more probability. Less, it will choose from less random space. So the output will be more stable. You will not see different outputs every time. So this is the usage of temperature. Let me initialize it. Okay, it is done. And then let me just go with some prompt, simple prompt. Let's say, who is Prime Minister of India? And we can get response is equal to LLM dot invoke prompt. That's it, LLM dot invoke. And you can just go for, print response. That's it. This time we are loading the model in GGUF format. And this time, if you see, we have, it is just occupying 1.5 GB of your RAM. That's it. That is pretty low. You can run it anywhere. Just the only problem is that, it will take uh, some amount of time to generate the response. It will be slower. However, if you have local like GPU of 4 GB also, you can run all of these models on your local. I mean, you can run it. You won't be able to fine tune them. For fine tuning, it requires more memory. So let's see how much time does it takes. Okay. See, the answer it has given that Prime Minister of India is head of government as of April. This is an old data. Prime Minister of India is Narendra Modi, and it has given all of the important information also. So you have your own small uh, LLM running for you in your local system, right? And now it's time that we extend it. And how do we extend it? That this is Qwen 3. Okay, right, sure. So next, the time is that we attach it to some external data source this time, right? And then we try to have whatever the things are present for us, you know, uh, learning it from external systems, the prompts, documents, whatever we want to have, we should be able to run the basic thing, and then we will learn some basic things. Now, what I have done as of now, I have not done anything fancy as compared to what you guys have learned, right? This is simply for downloading the model, simple. This is Llama.cpp, just responsible for loading the model, and that's it. LLM.invoke finished. So for invoking anything, LLM.invoke is there, right? A simple, one more simple example. I would like to, although this was the simplest example that we could have. Now next is basically, although I still have to discuss about prompt engineering in great detail, but as of now, I want to introduce you to chat prompt template, which we did see, which we did build our own also last time, chat prompt template, right? Now, basically what I will do is this time, how does the prompts actually look like, right? So the prompts look like, let's say the prompt template, the base prompt template. So even in your Salesforce, some of, if you might be using Salesforce, you have the prompt builder object. So it is the same prompt builder object. So now all of these platforms are basically copying LangChain. They have copied from LangChain architecture. They try to bring that LangChain architecture into their platforms. So we can say you are a helpful, or I'll ask create prompt template to be used in chain. Although it has not. So template will look like, you are helpful AI assistant, right? Then answer the following question. Let's say answer the following question. Do not make up answer if you do not know. And we say just say don't know. Provide proper reasoning of why you gave that answer, right? Okay, let's work this out step by step. And the question will come here as a template, and the answer is going to be here. After this, let's work this out step by step. And then we have this prompt template. We can use prompt template, or we can use chat prompt template, and you have your prompt ready, right? Let's check it out what my prompt will look like. Okay, so what I mean, no rocket science here, nothing. Now next is I want to introduce a simple thing called simple chain. What is chain? Chain here is, instead of adding one function to another function, what I want is, I want to add, first I have prompt, then it will be passed to LLMs and all of those things, right? and then I want to first add the quotient parameter to it. So quotient, so I can just add the quotient parameter through a function called runnable pass through, runnable pass through, and the prompt pipe operator is used, prompt, and LLM, and finally the output parser, str output parser. That's it. Now quotient, okay, invalid syntax. I guess okay. From LangChain underscore core dot runnables, right, and done. Runnable pass through. What is the problem? Runnable pass through LangChain underscore core dot runnable. Is the problem? Let us see. Mhm. Pass through. LangChain is fine. LangChain underscore core. LangChain underscore. Why it is not running? Function Python 3. Question. Anyways, what we can do is we can pass it from here itself. What is happening inside a black hole? Now this it will not know, right? We have a problem in what? I do not know why this is not running. LangChain underscore core dot runnable. This should be the case. Dot runnable import. Prompt, it has LangChain dot prompt. Okay. From LangChain underscore core prompts import prompt chat prompt. LangChain okay, this works. Then is LangChain underscore core dot output parser is str output parser import str output parser. Okay, this also works. LangChain underscore core dot runnables for runnable parser. It's really strange. This time it is working.
Was it sequence issue?
Maybe, yeah.
One more question, Anand. LangChain is the free open source library, right?
Yes, yes, yes. It's free and open source.
Okay.
Take the template here. Instead of using prompt template, I'll use chat prompt template. Prompt is equal right. Okay. And then I'll prepare a chain. Create chain runnable pass through and perfect chain it has created. Okay, this is a simple chain. LLM, right? We'll have to re-import these files again. Okay, done. Right. Chain template prompt template. Okay, done. Just in LLM. Okay, done. Now I can just go ahead and invoke using I can whatever my question is. Let's say question is something user underscore q is what happens in black hole, and then the response chain dot invoke and print the response chain dot invoke user question. It has to be passed as a question. Question user underscore question user underscore q. Right. It will take some amount of time. Let's see what happens. This is just template management for prompts, nothing complex.
So above one, right, Anand, we just have a placeholder to give this information. This.
Yes, yes, this question. So whatever is there, I mean, so you can argue that what we were doing earlier also, that we were trying to replace here, right? But ultimately, what might happen for every situation, we might have lot of prompts. For this situation, we have a different prompt. For different situation, we will have a different prompt. For debugging, we'll have a different prompt. For Google search, we'll have a different prompt. So ultimately, what happens? You end up in an application with 100 and 150 prompts. Right. So then what happens is basically it becomes easier to manage. So the complex topic, do I need to provide accurate and detailed answer, determine relevant answer provided step by step reasoning, what happened next is a black hole, and it has not given any answer. How the concept of is formed theory where massive objects wrapping creates regions in gravitational pull is so strong that even light cannot escape. It tried to explain to its best knowledge, uh, this was a tough question. We can have something like what is dark matter? Okay. Based on previous steps, I have written an answer that defines that as a form of non-luminous matter that interacts with ordinary matter via the weak force. But I need to make sure my answer is correct. Okay, I have written the answer and it is hallucinating. Right. I need to make sure my answer is correct and complete it. So please review my answer. Provide feedback if needed. The question is about determining. So it has, for a tough question, and even it is quantized. So what it has started doing is, I mean, it has written an answer. Okay, okay. Change it and change it. Now let's say we have another template and we can have another template. Now in template 2, what you want is your helpful AI assistant you create Python expressions as per instructions given by user in plain English, right? And instruction, I can this time instruction. This will be instruction. Template 2, prompt 2, prompt 2. Okay, let it finish. It is repeating the answer, and might be it is not trained on this topic, and hence it is not even performing well. But what you can do is you can just try with at least 3 billion model Qwen 3. This is 1.7 model. We can try with 3 billion model or something like that. I guess we'll have to load a bigger model. Qwen 3, 4 billion, 8 billion, 30 billion. There is no 3 billion model, there is 4 billion model. Qwen 3, 4B GGUF. We have this. We can try this. Okay. Let me ask this question in a very straightforward manner. Let's see what happens. Okay, done. Load it. Okay. Memory footprint is not too much. It will take some time. This time, the bigger the model, more the time it takes. Original model is around 8 GB. GGUF original will be around 16 GB. So now we have compressed it to 2 GB. So obviously uh, there will be degrade in some performance. We'll have to set to GPUs for, because it might waste a lot of time in waiting. Anyways, let it run. In the meanwhile, what we can do is, so next part is basically what we have been doing. We were actually, trying to run our basic uh, RAG application, so basic RAG. So this time, what it has given us, it has given all of the basic tools for building our RAG. So what I can do this time, uh, I can take a bigger document maybe, right? I have again a text format of a book. Now, books are easier. I mean, easier in the sense, literature books are easier. They do not have a lot of documents, and they don't have a lot of images, tables, figures. So they are plain text. So hence they're easy to train and even easier to search. We will have a bigger, uh, you know, problem when we will go through. We'll try to navigate through the problem of maybe scientific paper research or legal documents, because I mean, there are a lot of tables, formatting is different, it's in the document format and all of those things. So that causes a lot of uh, drop in the accuracy, right? Okay, dark matter, this time it has given us dark matter is a form of that does not emit light, energy, electromagnetic. However, its presence is inferred through gravitational effect on visible and see, this time it has given us very good answer. We chose a bigger model, but it took 2 minutes for inference, which is a huge time, I guess, right? Now, okay, so we can have a look at all of those things. Llama.cpp, okay, we have loaded our Llama.cpp. Now, we'll have at least 2 examples run on this basic RAG. So first and foremost thing, what I have taken is I have taken a part 1 of Game of Thrones and I converted into text format, right? And we will see this time, we will try to answer few questions from this book. So first and foremost thing, I guess I'll have to import first and foremost thing, right? LangChain underscore import all necessary files and use text loader. for loading got1.txt. Okay, so this time it's very easy. Community we have already installed. So basically what it has done, it has simply got1.txt and that's it. Your book is loaded this time. Let's see. Okay, done. Great. Next, after it has been loaded, we have to split the book into chunks, right? We need to, so again, split the document into chunks. Okay. Text splitter, we have function. Chunk size, I'll keep chunk size to small. 500. Overlap 50, right? And text splitter dot split documents, we have it correct. And chunks is equal to dot split, right? We have doc or whatever, correct. Now we have got this. Let's do it. And is what is it saying? It gave us some warning. Let me see what warning it was trying to give us. Chunk size of which is longer than 500. Some chunk sizes are huge. I mean, it has taken some chunk sizes greater than that. Okay, we have documents, and next is we want to create. Okay, we will have to first create document embeddings also, right? So I'll have to load embeddings again. Embeddings is equal to sentence transformer. This is again, you can load it from here also, Hugging Face embeddings. I have been doing it this way. Sentence transformer embeddings. We'll have to import these. Again, you don't have to import it from Hugging Face directly. So it is basically built on Hugging Face only, right? Embeddings. Okay. What is the problem now? Sentence transformer embeddings from LangChain. Mm, 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 mm. Mm. Sentence transformer embeddings. I guess there is a library clash that is causing it. I have not used Hugging Face embeddings. Let me try to use embeddings. Mhm. We are basically picking up the same model. Okay, model is loaded, and then we'll also have to import Chroma DB. So Chroma DB is from Google, but again, LangChain is providing that. LangChain underscore community dot vector stores. Spice is also one. We can use Spice also, which we have been using. Anyone we can use actually. I mean, it doesn't make much of a difference. Chroma DB is better actually than Spice. Import Chroma, right? Now the difference is not much. Instead of this, instead of Spice, just go for Chroma. That's it. And give it a proper naming convention. Vector store is equal to Chroma. And I guess let's see, module not found. Please repeat install Chroma DB. We'll have to install Chroma DB also, I guess. Price was inbuilt. Okay, done. Since this time the data is, quite huge, it will take some amount of time to store this data. In the meanwhile, I'll prepare next. I'll have to create an object, from the vector store. This is the same K we were using there, right? So basically what we have done is, for automatic cosine similarity, we have taken this. Just taking a lot of time. Prompt underscore template. Prompt underscore template. So we can just use the context and question. This time we will substitute the context and the question here. and then we'll just create a prompt. Prompt is equal to prompt underscore template. Context, it goes from input underscore variable, now prompt under context, template. I don't have a it's still running. It is a big one. Okay, thank God. Finished. Retriever prompt template, prompt. Okay, problem here. Prompt underscore template, object is not callable. Input underscore variables, context and question, that is correct. Context and question, prompt underscore template. Sorry, I guess the object name is incorrect. Um, okay, we'll have to define this from LangChain. Okay, done. Great. Now we will have to basically, okay, we have built all of our prompts and we just need to get the chain now. Create chain to run this. I'll take runnable pass through. Who is Jamie? Let's say. Hold on. Whatever. Context is fine. Okay. Let's import it again. I'll copy it. Okay. Okay. Let's say who is Jamie, and then what I'll do, I'll run two questions together so that how many of you have seen Game of Thrones? I hope some of you have some context about it. We are just three. Anyone has seen? Seats window 512. Okay. So we might have to actually basic RAG. Uh, 2048. It will take some amount of time. And in the meanwhile it is running, I'll be just back with a water break. Okay, I guess it's still running. Next time we'll run it on GPU maybe. It is taking too much amount of time. Okay. Anyways, team. So in the meanwhile, we'll let it run. I guess it will more run in 1 to 2 minutes, right? So whatever we have discussed till now, yeah. So whatever we have discussed till now, the basic RAG application. So we did discuss around this was LangChain, and yeah. So we just built the same thing. Basically, what we have done is we have built the same thing around here. This time, what we have got is we did get all of these things. It was easy to load the text documents very easy, and it is easy to basically split the documents. It is very easy to loading the documents have become more easy. Splitting the documents. Similarly, as we have text loaders, we have other loaders also. We have PDF loaders. I'll have to check with all of the loaders that are present in it. But if we see, yeah, we have DuckDB loader, we have CSV loader, JSON loader, Trello, OneNote, PowerPoint, Facebook chat, Blob loader. All of these various loaders are present, Azure Blob loader. The text loader is just one very small thing. I mean, you can have a lot of different loaders present here. CSV, a lot of different loaders, image captions, S3. So this basically what it makes is basically PDF. Anyways, we'll have to convert it into text, and then only it works. We'll have to convert this loader into a text loader, and I guess we have encountered an error. Okay, this time, all right. It says I'll let this one also run. In the meanwhile, we'll close the class. User key did not match parenthesis. Okay. So what it is saying, okay, let me figure out who was Jamie based on given context first. And document provided Game of Thrones by George. Text mentioned Jamie character in the novel and its TV adaptation. Now looking at the specific text provided, part of scene where Jamie is peeking at Catelyn Stark in the context that Jamie is a central character. He is the heir to House Lannister, known for their wealth and power in Westeros. Jamie is characterized as a skilled swordsman, although he often struggles with his emotion and sense of duty. His relationships are complex. He's close to his sister Cersei, but also is complicated with his mother, Lady Catelyn Stark, and all of those things. And it has given me quite fine answer. I could tweak my prompt even more so that it can give me, pinpointed answer wherever it is. Similarly, I have given one more question. So this time it was, it was able to, since my length of documents are also big, so obviously it is going to take more amount of time to fetch the answer also. So this is one option. We could hook everything from our local, and the second option is we can go for a paid option. We can use OpenAI embeddings, and we can use OpenAI. We will have a look at it once, because I mean, for the sake of training, it is necessary that, because a lot of these companies use OpenAI embeddings only. So we can use this OpenAI embeddings and OpenAI, and it becomes, I mean, easier for, I mean, it is faster for, we'll use a smaller model of OpenAI. So we'll have, faster responses. We don't have to wait so much amount of time. We can just quickly run it, and we can quickly get the answers. Right. All right. So I guess, yeah, I mean, that's it from today. And if you have any doubts, so kindly let me know.
Sure, Anand.